Hi everyone. This question given here is the following is a probability density function. So of a continuous random variable for the x here. So when we're dealing with continuous random variable, we will always use the tool of interval so that we can visual the function clearly. We can see our function 0 to 2 and 2 to 3. So for this interval continuously 0 to 2 is 1 over 3x, 2 to 3 is 2 over 3 and then 3 minus x. So for the first question is they're asking us to draw the graph. So we are going to draw this piecewise function. So for the first piece, 1 over 3x is a linear. Starting point 0, ending point to 2. So for x, we calculate our starting point. When x equals to 0, y will be equals to 0. When x equals to 2, y will be 1 over 3 times 2, so 2 over 3. So this is our first piece. And then second piece, coordinate start with 2 and 3. So therefore, starting point, when x equals to 2, put in our x here 2, 3 minus 4, 2 is 1, y coordinate is 2 over 3. And when x is 3, our y coordinate will be 0. Then we can draw out our graph here. So label our axis as x random variable, y-axis as a probability here function. So we have 0 and then 1, 2, and 3. So we start do this piecewise function plotting. For the first piece, when x equals to 0, y equals to 0, this coordinate is included. So it will be a 10 circle here, starting point. Ending point also equals to 2. So y equals to 2, x equals to 2, y is equals to 2 over 3, 10 circle. So to join these 2 points for this interval is a linear graph. So it will be a straight line. Then continue for start from 2, when x equals to 2, y is 2 over 3. At the same point here, it continuous. And when x equals to 3, y is 0. So here. So for second function here, as we expand, it is 2 minus 2 over 3x. It's a linear graph also. So we will draw it with straight line. So here we have our probability density function graph. Then we proceed. So after we sketching the part of the graph, we have another part here to say that to show this x is a continuous random variable. So to show this x is a continuous variable, where we're going to find for its total area. So we were going to integrate negative infinity up to infinity for the function and dx. So we will see, is it the total area under the graph, is it equals to 1. So we have two pieces of function here. So our total area under the graph involving will be start from 0 until 2 for this 1 over 3x, 2 until 3 for this 2 over 3, 3 minus x. So we integrate this, power plus 1 over new power, substitute upper limit minus lower limit. Same as here, the coefficient we factorize out. So 3 integrate we get 3x, x we integrate we get power plus 1 over new power. So the next step is we're going to substitute upper limit minus the lower limit. So we have 4 over 6 here. And 2 over 3, this is 9 minus 9 over 2 minus 6, 4 over 2. So we can evaluate this using our calculator, we can get 1. So once we get 1, we cannot just simply write shown. You have to prove it into the sentences given here, where x is a continuous random variable. For the first part, A, finding the probability for x less than equal 1. So for continuous, we are not focusing on equal or not because it's always continuous for all part of the graph. We are going to see the area under the graph. So the area under the graph for x less than 1. So we're going to integrate for this area, start from minimum 0 up to 1. For this interval, 1 over 3x and respect to x. So we do power plus 1 over new power, upper limit 1, lower limit 0. And then substitute upper limit minus lower limit, we get 1 over 6. So probability for continuous random variable always integrate that area under the graph. Then we can continue for second part, B, which is finding probability x more than equals to 0.5. So we look at the area. 0.5 is 4 on this. So more than that, we want all this area from 0.5 until 2, then 2 until 3. So we have 2 piece area to find it if you want to calculate directly. So our integration here, we have 2 options. The first option is we integrate 0.5 up to 2 for the function 1 over 3x, continue 2 until 3 for the function 2 over 3 minus x dx. But this one, I think the calculation will be more longer. So why not we do it reverse way, which is 1 minus the part that we don't want. So the part we don't want here, the area we don't want here is 0 until 5. So therefore, I can take overall probability, which is 1, and then I minus out the region that we don't want, which is integrate from 0 until 0.5. For the function, respective function is 1 over 3x. So power plus 1 over new power, substitute 0.5, then minus lower limit 0.0. So simplify this, we can get 13 over 24. It will be same as you adding the area under the graph region by region. It will be same answer actually. So you can double check it with your working and your calculator. To double check with your calculator, so the value we will get here is not 13 over 24, it is 23 over 24. Then we proceed. For the question C, so for the question C, you can see our random variable is involving modulus. So first of all, we simplify this modulus definition first. Modulus less than. So when you want to open this modulus less than, it will be negative 0.5 less than x minus 2 less than equal 0.5. So it will be in an AND definition. We simplify this modulus less than, so we put negative for this value less than equal. Then we simplify the 2, we take out 2. When we plus 2 here we have 1.5 and we plus 2 here, which is 2.5. So our area we need to find is 1.5 until 2.5. So 1.5 is here until 2.5. So you can see this area under the graph is involving two functions, which is 1.5 until 2, 1 over 3x function, and then 2 until 2 over 3 minus 3x is another function. So we have two pieces of the area here. So to find its probability, we integrate start from 1.5 until 2, 1 over 3x dx plus 2 until 2.5, 2 over 3, 3 minus x dx. So we start integrate that, power plus 1 over new power two over 3 we factorize out. So integrate this 3 we get 3x, integrate x we get power plus 1 over new power, upper limit 2.5, lower limit 2, then we perform upper limit minus lower limit. So here we can get 13 over 24. Then we continue. For the next part is finding the mode. So as we can see from the graph here, the highest probability point is 4 on 2 over 3. So therefore, for question D, the mode will be the random variable x equals to 2. That is the highest part we can see. So that's all for this. Thank you for watching.